All right, now I have to fix something. We're now on the pH scale, which is a few pages later after what I just said. I did the math right a second ago, but I kind of messed up. Let me explain. On the previous example, I had 1 times 10 to the negative third. I'm already off to a good start. And 1 times 10 to the negative 11. And then, if you remember, I said I increased this, so it became 1 times 10 to the negative fifth. Now, that's kind of dumb. Obviously, those of you that know anything know that an increase in a negative exponent meant making it smaller. All right, so correctly, I actually decreased that. All right, that made this be 1 times 10 to the negative 9. And that increased that. All right, now I don't know, maybe you didn't even catch it, but I said it wrong because I forgot I was dealing with negative exponents. The math is still true, and the relationship of being inverses is also true. Okay, now back to the pH scale. I'm not sure. I think this is probably on page 7 or 8. The pH scale. I'm actually shooting a video or making a web page of me, and then I'm going to walk through my web page. So let's just go ahead and I'm just going to go there now. Strangely enough, you're actually looking at my subplan right there, even though it's not right. Move. All right. This lab book has a ton of resources right here. It's this acid lab book. Click on it. It's a little bit different design than some of them, but well, it looks like I fixed most of it. But for right now, we're going to do the pH scale. You can certainly do this at home. If I made this a little bigger. The pH scale is the third link down. You can click on that at home and you can fill this in. I don't know why that's not what I wanted actually. Yeah, it is. Never mind. This is where I want to be. Okay, so the pH scale. I'm going to have to blow this way up. All right, the acidic, basic, or neutral character of a solution can be measured and reported using the pH scale. Little p, big H. All right, pH is shorthand for the concentration of the hydrogen ion. All right. It also kind of means the power of hydronium or hydroxide. If it's POH, that would be hydroxide. pH values commonly range from 1 to 14, although some very basic or acidic solutions may be outside this range. Not in this class, they won't. We will always stay between 1 and 14. But I do have some acids in the back cabinet that are past a 1. And I don't know if my base is past 14, but it's very strong. All right, the next piece of notes, we have a pH of 7 is a neutral solution. All right, so that's right there in between the middle of 1 and 14. So that should make sense. All right, make sure that you underline and understand, or at least know, the next two sayings. That first, the pH values below 7 are acids. And the lower you get, the closer you get to 1, the more acidic it becomes. So hydrochloric acid is very acidic. It's right there at a 1 value. Acetic acid or vinegar is not a very strong acid. So its pH is a little bit strong, or a little bit higher. It's still an acid, but more like a 2 or a 3 instead of a 1. The soda pop that we drink is slightly acidic. It has about a 3 or a 4 pH because of the carbonic acid that they use to carbonate it. Okay, so those are acids. They're below 7. pH values greater than 7 indicate bases. The higher the pH, the more the basic the solution. So our laundry detergent, which is a strong base, is around a 12 or 13. And bases are just as dangerous as acids, even though we don't talk about them.